Assalamualaikum and good day. My name is Aina Fatin Binti Ahmad from AS222 Today, I will present to you about my industrial training. My place during industrial training is at Union Laboratories, Sendirian Berhad. The laboratory is located in Perai, Penang. My supervisor is Mr. Lam Meng Hui. Now, let me proceed to company and department background. The Union Laboratory Sendirian Berhad is a commercial testing laboratory in Malaysia that is established on 7 January 1983. Union Laboratory Sendirian Berhad are committed as researchers, laboratory analysts and testing lab. The laboratory carry on experiments on all kinds of industrial, construction, food, agricultural and mineral. I was placed in chemical division. This division is responsible testing food, feed, fertilizer and soil, oil and miscellaneous sample. This division ran lab on ash, moisture, protein, fat and salt of the sample that clients have sent to be tested. The organization of Union Laboratory Sendirian Berhad start with managing director, followed by executive director under customer service and after that maintenance officer. Under the customer service, there will be site sampling undergoes by technician and laboratory assistant. Then, in chemical technical team, there will be have chief chemist and the team is divided by 3 teams. First is chemical division 2. There are division head and assistant chemist. Second, chemical division 1 that have division head, chemist and assistant chemist. Third, pharmaceutical division that have division head and chemist. Besides, we have quality manager. And lastly, administration led by account officer, laboratory coordinator, assistant coordinator and admin clerk. The business nature of activity in this laboratory is to act as researchers, analytical chemists and industrial consultant, biochemical, chemical and microbiological testings. Now let me proceed to task and project. During my internship, I have been given 3 tasks to complete. The first task is determination of beta-carotene. The introduction for this task is beta-carotene is one of the light-absorbing pigments in palm oil sample. Because it mostly consists of carbon single bond with carbon, carbon double bond with carbon, and carbon bond with hydrogen, beta-carotene is a non-polar hydrocarbon molecule. In this lab, 3 techniques were used to extract this compound from palm oil, which are solvent extraction, column chromatography, and UV spectroscopy. The objectives of this task are to separate out beta-carotene and to identify the concentration of beta-carotene in each sample. For the procedure, I have to extract the sample. First, I have to chop and grind the plant material. Then, place 5 gram sample in blender. Add 40 ml acetone and 60 ml hexane. Blend for 5 minutes. The solvent been filtered and the extract been kept. The residue in the blender been washed with twice 25 ml of acetone and 25 ml of hexane. The extract been combined. The extract been poured in separatory funnel. Wash the acetone from extract with 100 ml of distilled water. Repeat for 5 times. Transfer the upper layer to 100 ml volumetric flask containing 9 ml acetone and dilute to volume with hexane. For the column chromatography part, pour extract into the column chromatography. Acetone hexane being used to wash the carotene. Pour until yellowish orange color fades away. The eluates then been collected. Pour into round bottom flask and use the rotary evaporator to evaporate it. Transfer into 100 ml volumetric flask. Dilute to volume with acetone hexane. Then, turn on the UV machine. Set the wavelength to 436 nanometer. Pour into the cuvette and calibrate the sample. The result obtained for the sample is shown. Due to the lack of a conjugated system of bonds and atoms with lone pair of electrons, the solvent acetone and hexane do not absorb UV spectrum. Therefore, they should not have impact on the spectra of carotene. When doing the UV spectroscopy, the results can be improved by using hexane as blank. This is because the main solvent for beta-carotene is hexane. The cuvettes must clean and dry surfaces that are free of fingerprints. During UV spectroscopy, any surface debris could result in light scattering. The spectrometer will mistakenly perceive this as photon absorbance, and the resulting spectra may exhibit abnormal absorbance peaks. In conclusion, beta-carotene are separated and isolated by column chromatography. Due to the conjugated system of double bonds in molecules, molecules absorb photon in the region of UVB spectrum. For the task 2 is determination of moisture content. One of the most often assessed aspects of food ingredient is moisture content. Legal and labeling regulation, economics, microbiological stability, food quality, and food processing operation are just a few of the factors that make it crucial to food manufacturers. Therefore, being able to accurately assess moisture contents is crucial for food scientists. The objective for this task is to understand how crucial it is to know how much moisture is in food and other biomaterials and evaluate the experimental data. The procedure for this task is to first crush the sample, weight the empty petri dish with lid labeled as W1, put 5 grams of sample in petri dish and record weight labeled as W2. Transfer petri dish with sample in oven for 4 hours. Remove from oven and place lid on petri dish. Cool in desiccator and record the final weight. The result obtained for the sample is shown. We can see that the weight after oven decreased. Due to the heating, water is eliminated. Water vaporization causes a loss in weight that is accounted as moisture weight. As to get the accurate result, the mass recorded only after the food sample get cooled in the desiccator as to ensure the temperature not affecting the mass. Other than that, weighing process done in a closed place as to get the exact weight. This experiment done with duplicate each of the one of the sample as to ensure the difference between result is not too big. In conclusion, the moisture content been determined by using drying method and the result obtained was successful. There are no big difference of moisture between the sample. For the last task is determination of ash content. Dry ashing is high temperature incineration carried out in a muffle furnace. Conventional dry ashing has the benefits of being a safe process, requiring no extra reagent or blank subtraction and requiring little monitoring once fire starts. The generated ash can be utilized for analysis such single elements, water-soluble and insoluble ash. The objective is to determine the ash content in the sample. For the procedure, the sample being crushed and sieved. The empty crucible being weighed labeled as W1. 5 grams of sample were transferred into crucible and weight being recorded. Ignite sample at 550 degrees Celsius for 1 hour. Then heat up to 750 degrees Celsius for 2 hours. Cool crucible in the desiccator and record final weight of crucible with ash labeled as W2. The result of the sample is shown. The composition of the resulting ash is different from the inorganic compounds found in the initial sample. All water is lost during incineration, as well as carbon dioxide is lost from carbonates. Iron pyrites are transferred into ferric oxide and other chemical processes. The weight of the crucible and the sample that was burned in the muffle furnace to produce ash reduced. This suggests that as the sample burned in the muffle furnace, which creates an extremely hot environment for the crucible containing the sample reaction to the heat causes them to break down and release oxygen. The sample lost mass when the water vapor was released. In conclusion, the sample heated in a furnace underwent a chemical reaction in which the molecules of one substance broke apart and joined those of another substance to form a compound. This compound, which is a combination of different molecules, produced ash. Then let me proceed to impact of industrial training. An industrial training facilities where students can put what they have learned from their study thus far into practice while in training phase. For example, I get to use pH meter in the lab, which I did not have chance to use in my university. Industrial training really boosts my motivation and commitment to work. I get the chance to work in the career I want to pursue in a real-world setting and receive lifelong learning experiences. I had chance to cooperate with specialists and learn about the real-world application of my educational environment during industrial training. For example, I get to use machines such as UV spectroscopy. I also get to enhance to work in a teamwork and develop my speaking skills. This industrial training gives me pre-professional job experience. This can train for me to get used when I have a real job. Lastly, let me proceed to conclusion and recommendation. During 15 weeks of internship, I gained the understanding of working as a worker despite having no prior experience. It was a great experience since it allowed me to put myself in a new environment and experience the life of a worker. This is quite different compared to university life, which I can say that I have to force myself to be creative, accept the advice from the senior, and so on. In general, I believe I will meet the internship objectives since I am familiar with the work given to me. I was able to increase my technical abilities as a result of my internship, and I was able to include this new professional experience on my resume. After 15 weeks of undertaking industrial training at Union Laboratory Sdn Bhd, I would like to suggest Union Laboratory Sdn Bhd must improve to make industrial training more efficient. There are several recommendations. First is to provide a better fire extinguisher, safety showers, IWAS station, and fume hood. Second is to provide an appropriate supply of first aid equipment and instruction on its proper use. Third is to upgrade from paper. The advantages of digitizing laboratory are extensive, but a few reasons include saving time finding information already written down and reducing waste paper and storage space. Therefore, going paperless will save time and effort. It may also promote staff well-being and improve the scientific output of the lab. That's all about my industrial training. Thank you.